So yeah, I
Or
just
oh yeah,
to
it
introduce
started
you,
right now.
yes. So today we have a special guest from the Czech Republic, and who's going to talk to us about an aspect of cryptography that we don't often see, but is also very important. Is the interaction between cryptography and humans. Um, and so she's not going to present about cryptography. It's not just math and programming, it's also people. So we are very happy to have you, and the floor is yours. Thank you, Ivana.
Okay. Thank you. Hi, all. Thank you, Francesco, for inviting me to have a talk here at Crypto Cafe. So first, I want to say that I'm very nervous, but I hope it will bring something inspiring to you, and it's not just all the stuff that you have already heard about. So cryptography is not just math and programming, it's also people and sometimes mythical creatures, but I will answer that in 1 hour. What's the creature there? So something about me. My name's Ivana. I'm a PhD student at the Czech Technical University in Prague, and my research is in human factors in post-quantum cryptography. And I also teach cryptography, like an introductory course. So to place my work life on a map, I'm based in Prague, but I often go to Germany to work with people from Bochum and from Hanover, with the university in Hanover and the CISPA. I just wanted to say that because all the research that I will be talking about is a shared research, or I collaborated with these two groups. All right, so what is on today? I would first like to talk about human factors. Why do we even study them? Then I will talk about one of our papers, which mapped the cryptography ecosystem and was talking about the challenges to cryptography adoption. And then I would like to shortly talk about my current work, which is focused on cryptography competitions. So why is technological innovation not enough? I will try to answer that question to you right now, because I think that probably all of you are studying or working in cryptography, which is more on the mathematical or technical side. So in general, we are in the field of security, or computer security, information security. And I suppose that we all can agree on security being quite hard. So when we talk about functionality of a system, we mean that if a user does something expected, then the system does something else. But security, there is a different principle. If a user or outsider does some unexpected thing, then the system does not do any really bad thing. And the problem is with the unexpected, how to prepare for any unexpected thing. That's why the security field is very hard, and sometimes it's very hard to prepare for all the things. At an introductory course at my university, they would teach us about this triad, the traditional security goals. I suppose that you may have seen something like that. And so how does the security research typically tackle the problem of achieving these goals? Any ideas? So I will answer that question. Maybe it's so obvious. So by inventing new technologies, and we have indeed there are a lot of impressively strong security and privacy mechanisms there. We have authentication and access control mechanisms. We have cryptography, end-to-end encryption. We have email encryption and secure messaging and a lot more stuff. But then in reality, users still choose to use insecure passwords, and often company compliance rules do not enhance security, and there are many jokes about that. There are misconceptions about secure messengers, and some people choose not to use them because they prefer the insecure ones. And almost no one uses encrypted email. So the easy thing to say would be, well, let's just blame the user. The users are useless and they are dumb. But I would say that it's maybe easy thing to say, but it's very hard to do. We can't change everyone, and here you can see one of my favorite papers from the 90s from Anne Adams and Angela Sasse. And their title, yeah, it's same my stand on that. The title is "Users Are Not the Enemy." It tells us not to fight with the human nature, but instead of that, try to be respectful and understand what people need and want. And instead of fighting them, maybe we should try to understand them. And them, I mean, not just users, but people working with technologies, not just end users or of cryptography, but also the creators. Okay. So now that I tried to make a case for human-centered security, let's talk about my research. So I have a bachelor's degree from cryptography, and I learned it as a part of mathematics with all the Alice and Bob and Eve and Mallory and descriptions of schemes, and it was all very, very elegant. So in the ideal world, it would be great if it worked just like that. Very smart cryptographers, mathematicians, designing schemes, then probably competing in competitions and implementing what they designed. But we, as researchers in human-centered securities, we were not sure that the process is really that easy. So we decided that we would discover and study the challenges of bringing cryptography from research papers to products and to end users. This is a paper from last year's Usenix. So our premise was that there is a big pile of cryptography research output, but many ideas don't get deployed. And we wanted to discover the systemic blockers that hinder the adoption. So to discover that, we interviewed 21 cryptography experts with roughly 10 to 30 years of experience, with backgrounds from academia mostly, but also industry, nonprofit, and governments. And we did a thing called qualitative research. We talked to the people. These were mostly semi-open interview-led interviews. And then we did a thematic analysis of the transcripts. We were talking to them about their background and experiences in cryptography in general, and their view of adoption blockers and paths forward. And after talking to them, we tried to make a map to visualize the cryptography adoption path. This is very simplified. It just emerged from the interviews as a simplification, as a model of how is cryptography created, how does which professions need to be there, which stakeholders, and even though there are many groups and many actors or roles there, it kind of looks very simple, I think. It goes from left to right. Maybe I can go through the map very quickly. So on the left, we have people that design algorithms, schemes. We have cryptanalysts that try to break those ciphers. Then protocols are created and applied cryptographers are implementing that. And here are standard development organizations that create cryptography standards using the schemes. And then when we go to the right side, that's the applications, and it goes to a system or a phone of an end users or to an organization. That's very simplified. Oh, that's also we discovered that it's actually, in fact, not this easy. And this is just, what would be the word? This is also just a simplification, but what we discovered is that at almost every arrow in this graph, there is a systemic problem or a challenge or a barrier. So when we studied that, we tried to make a list or make categories of these challenges, and we made five of them, and I will go through them individually. So these are the biggest adoption blockers. One of them is misaligned incentives in academia. And I would say that there is a big probability that every one of you sitting there is maybe has an opinion about this. But from our participants, the biggest topic was that they are not incentivized enough to really do the applied work and to connect with, for example, to connect the theory with standards and with applied cryptographers. These are quotes from the interviews. So, for example, one of our participants says that practical impact does not get you papers at crypto, being one of the largest crypto conferences, which is something that an academic needs for survival and needs to publish at conferences. or another participant said people won't get that much academic credit for spending like 3 years flying to IETF meetings and fine-tuning a standard. So maybe there's an academic incentive problem. And if we or if academics don't get incentivized to do the work of, for example, fine-tuning a standard, to work at standards, then there probably is a gap. And standards are the things we need to actually use the cryptographic algorithms. And therefore, probably academics don't do that enough. Okay. Another challenge, which is quite connected to that, is that standardization processes are very tiring, tedious, boring, and are unrewarding work. This is talking about the same thing, but maybe from a different point of view. One person told us there are a lot of cases where the same words are used to mean different things and different words used to mean the same things. There's also a problem with language. People, even though people in cryptography are in the same field, people that do, for example, theoretical cryptography and people who implement things may often speak a different language and have different terms for things, and they sometimes just don't understand each other, which is one part of the problem. And other part of the problem is that they need to work together, and also they have expectations that the other part of the cryptographic community speaks the same language, and sometimes that can lead to misunderstandings. And yeah, so a big topic that emerged from these interviews was the need for someone called it a crypto plumber, someone who would connect different bubbles of experts. We see here that there's not many people sitting in the middle to translate between the worlds. I think there's like a half of a dozen people who are able to do that. And I'm not sure if I agree with this number, if there really is 6 people in the world that could do that. But it points to a problem that the translation between, and it's not even different scientific communities, but within the scientific community, it's a very difficult thing to do. Okay. Reference implementations were also a big thing. They are a very useful tool when people are implementing crypto, but they are often not thought to be production code. For example, here, my reference implementations were never production ready. They were reference they were reference implementations. Maybe this is not a great quote because it's maybe difficult to understand, but the problem sometimes was that there is a difference between a real reference implementation and an actual implementation with all the optimizations. And so one implementation is meant to be read by a human and understood, and the other is actually deployed. And people might use reference implementation that is not intended to be used if it's, for example, not labeled. Then also I think about communication. There is a shortage of translators between theory and practice. That's something that I have already talked about. Some people are using the words, that's the job of someone else. There is a problem of responsibilities between theory people or implementers, and sometimes some of the tasks are not really done by anyone, because all of the people and parts of the community think that it's not their job to do, to think about that. It's someone else's job. And when everyone thinks that, then no one does a task. But this one is slowly becoming better. Okay. The last category of the challenges was low usability. So this is also about reference implementations. Sometimes they are hard to understand, and this also is connected to expectations. So this first quote talks about expectations of what the reader already knows, but actually doesn't know. One trick, for example, is if you got anything that relies on a floating point and people want to speed it up, they change it to fixed point. And there are people who don't know about fixed point arithmetic. So this is about skills of the people and expectations of their skills. And another thing is a clash with desired functionality of end users. Deploying crypto takes away features that people really want. It takes away easy recovery, backups, text search, or fancy AI features that people want to do. I have seen that especially with encrypted email. People don't want encryption. They want easy backups and search over their mail history. And this is, I think, very understandable. Security is not always the primary goal of people. The goal of people is to enjoy their technologies or to do their job and not to focus on the security. So that's why it's very important to make secure things usable, because when they are not easy to use or not enjoyable to use, nobody is going to use them, and we can't really blame anyone. Okay, so to sum it up, it's a bumpy path, but not hopelessly. We came with 3 categories of recommendations, and these are just the ideas of what can different stakeholders do to make the problems a little bit better. But I think none of the categories of the challenges has a simple resolution, because if it's about communication or about money, about funding, about incentives, it's all systemic. So I'm sure that our paper didn't really like save the world, but we tried to make the problem a little bit more understandable and yeah, and easier to know what to do. All right. So before I talk about my current project, which is cryptographic competition. I wanted to ask if anyone has a question.
Okay.
Okay, I heard that someone said something, but I don't really understand it
No,
because
I have one question. So why do you say for the industry people you have to be more transparent? Like, what does that mean?
Okay,
Like
please,
the codes are
Francesco,
all
could you?
I mean, it's mostly open source, right?
Did you get the answer, Ivana?
No, I didn't get the question. I just hear it, but I don't really understand it because of the room acoustics.
Should I make it?
Well, it should be a mic,
Yeah,
but yeah.
Maybe louder.
Yeah.
Okay. So why are you telling that industry people have to be more transparent in cryptography? Like, for example, this end-to-end encryption in WhatsApp. Like, don't you think it's already transparent? Or I am not sure. Like, I'm just asking.
Yeah, so you are asking why do we recommend industry to provide transparent cryptography? Yeah, so I don't think that for example, WhatsApp is well, that's debatable, but definitely I would think that if the application that uses end-to-end cryptography is transparent about what they are doing, I think it's better for users to understand why do it's easier for users to decide which app, for example, they should use. Or do you think that they are transparent? Maybe I didn't get the question.
Like, is there any, I mean, like, what's a normal strategy? Like, how transparent it would be for a better understanding?
Okay, so for example, I think that for example, WhatsApp is a little bit better than Facebook Messenger, and I know that both of those messengers are now under Meta, but historically they were not, and it was so much easier to get the information of what WhatsApp was using because they published their white papers, and it was quite it was not so easy to find anything about Messenger. But for example, I would say that I don't know about America, but in Europe, a lot of people use Telegram and think that that's a tool that's very secure. But in fact, I would say that it's not so secure because, for example, Telegram doesn't encrypt their chats as a default. You have to switch something to make it secure or make it encrypted, and they are really not transparent about that. They just don't say that anywhere. So this is one of the things that I am not saying they are lying, but they are really not transparent about what they do. They just say that they are secure, but I would say that that's not enough.
There's another question from the audience again.
Some companies move to open source to address this. Is that something that Ivana sees as a transparency, like positive?
Did you get that, Ivana?
No, sorry. Can you, Francisco,
Could you
can
say
you
something
maybe
about-
repeat it?
Could you say something about open source and if that affects positive change in this sense?
Yeah, if a company is open source, that's definitely better. But the important thing is how do they communicate it to the people that use the application. So if it's only open source, but their communication is not very accessible, then just people that are like very into that and know enough about the topic will actually get the message. Did I answer you? Okay.
No more questions from our side.
Okay, so let's go on. So right now I am working on a project that studies cryptography competitions, and I wanted to ask you, but maybe I will just say it. Probably my expectation would be that when I say cryptography competitions, you think about NIST. But one thing that I discovered that it's not just NIST. One disclaimer, it's that this work is not finished yet. So it's not a finished paper. It's not under review yet. So it's unfinished. The things that we are trying to discover and the questions that we are asking are cryptography competitions the best version of themselves? And then also, how do they contribute to security of cryptography? What are the deciding factors for competitors and the reasons for participating or not participating? And what about geopolitical impacts? That's just some of the questions. So to give some context, here I don't really know much about the general awareness about crypto competitions. Maybe I will just say things that all of you know, but maybe not. I will just say them anyway. So this is our simplified timeline of the biggest cryptography competitions. I will show you, this is the first half. We also included DES, which is not exactly a competition, and it's not technically a NIST competition because it was a standardization effort that was quite closed, and it was done by NBS, which is the previous name of the organization NIST. But it was the first idea of putting together people from cryptography and using their knowledge to create something new and to standardize that. And as the first cryptography competition that was open and international, which is probably one of the most famous, that was AES. Then there was NESI and eStream, which were European competitions, not organized by NIST, but by people from Europe, from academics. And I would just say one thing, that like sometimes when I was researching the history of competitions, I think it's a funny thing, but sometimes something like unexpected, sometimes I discover something unexpected. So, for example, the reason why eStream competition happened, which was a competition of stream ciphers, that happened because the previous one, NESI, also included the category of stream ciphers, but all of the candidates were broken, so therefore they had to do another one and create some new things. So these two didn't end up in a standard, but in a portfolio of recommended ciphers. Then we see SHA-3, which we now use today. And here, so this is not exhaustive. There are more competition, but these are the competitions that appeared in our interviews. I also wanted to say that the method for this paper was the same. We also interviewed people, and it was also a qualitative research. So we chose to display competitions that we talked about with the people. We see that, for example, the post-quantum cryptography competition is the longest one yet, and the additional part still hasn't finished. Okay, so this is the background. And even though it's not finished yet, there are topics emerging from the interviews. For example, the most emerging topic, everybody talks about trust. For our participants, trust is very important, and I mean trust in the organizer is very important. But fairness, not necessarily. So this is not what all of the people said to us, but the vast majority. And why fairness is not important. That's something that was really interesting to me. And the thing is that there is even though we call competitions, maybe the better term would be standardization efforts. And there is a big difference between a conquest or competition, for example, 100-meter race, which should decide who's the better runner. But here the competitions are not about who's the better cryptographer, but it's an effort, but not necessarily collaborative, but somewhat collaborative effort of the community of creating the best thing that we could create and the most secure and fast algorithm. Then cryptography competitions shape the community, not just the other way around, which would be more obvious. But cryptography competitions more and more have a really big impact on what people do, what are people funded and incentivized to do. And it has a really big potential to dictate what people are doing right now and to dictate the trends. Then competitions need mature community to be successful. Competitions need to have good timing. And if a competition for a specific type of scheme would be organized, for example, 10 years before, it wouldn't have the same kind of successful results. One of the like darker topics was that personal animosities can scare away potential participants. And by personal animosities, a lot of people were saying that you have to have a really thick skin if you want to be the part of the conversations, and you have to be very competitive, because competitions are not just about designing a fancy mathematical construction and then implementing it, but it's also about arguing with other people and trying to defend your ideas. And this could potentially scare away people that are, for example, younger and not really or starting in this field, which would be a really big waste, because that would scare away potentially good ideas that would be otherwise successful. Because maybe some of the communication channels are not moderated enough. That could be one of the reasons. And lastly, the world is not exactly united. And this is one of the last parts of the talk. This is just a topic. I'm not going to say anything definitive about that. But from what I could hear in the conversations and in the interviews, cryptography competitions are mirroring the geopolitical state of the world. And I'm going to cite a paper from Phil Rockaway, The Moral Character of Cryptographic Work, where he says, cryptography rearranges power. It configures who can do what from what. This makes cryptography an inherently political tool, and it confers on their field an intrinsically moral dimension. He talks about a lot of topics in the paper, and I think it's very interesting to read that. But why did I add this site? I created a map, which is not it's an ongoing research. So we have a lot of blank spaces there. But from what we see, the process of adopting, this is about PQC standards adoption. The process of adopting kind of copies the geopolitical state of the world. So it reflects cryptography as being a political thing. What I mean by that, so in darker blue, we have USA, where NIST is located, and this is, in one sense, it's an international thing. Like everyone from the world could participate in that competition. But then we could also say it's not an international thing because it had a US organizer. So some of the people were pointing out, well, a lot of Europeans got funded by European governments to participate in the competition, but then NIST got to choose the winners. So that's a really nice thing for NIST, and a really cheap way how to get standards. This is also an overly simplified statement. Then in light blue, we have countries that are adopting NIST standards, the results of the PQC competition. And from what I recently read about Ukraine, they are also adopting these standards, but with some tweaks. So that's a different case slightly. Then we have, in the red one, we have China and Russia, which are obviously having their national standard efforts and national competitions. You may have heard about a Chinese competition. And then there is KPQC, which is, for me, it was the most interesting one, because I would say that it's a semi-international competition that's in South Korea. Why do I say semi-international? I mean that in that competition, all the teams that participated had to have at least one person from Korea. And the special, so there are pros and cons of national competitions. One of the biggest pros that by having a national competition, they have something that they don't have to rely on an American institution to tell them what to do. They have their own thing. But then the Korean cryptographic community is much, much smaller. And even though they also had international people, I spoke with someone, some people from Europe, for example, that participated there. Their participation was very limited because of the language barrier. So there are pros and cons of these competitions. And with that, with the Korean competition, I would like to slowly end my talk, which brings me to this mythical creature. It's called Haete. I don't speak Korean, so I hope I'm not butchering the pronunciation, but it's one of the winners of Korean PQC. And it's called, or its name is after a mythical creature from Korea. And this lion with horns is said to be the guardian of law in Korea, which I just loved. And I wanted to end with this thing because even though it's very technical and very mathematical, you can still see people in that. So thank you for the attention, and if you have any more questions, I will be happy to answer them. Thank you.
Thank you, Ivana, for the very interesting talk. So any more questions from us, from the audience, also from on the internet?
So I just have a small question. What is the country, like the small blue country in the map in South America?
Which one? Sorry, in the map?
Blue, yeah.
It's French Guiana, I think.
Oh, I see. Okay.
So it's French.
Yeah, it's
Oh,
French.
I see.
It's French. It's French because it's technically part of the EU.
Okay.
And the reason why the rest of the world is gray, it's because there is very little research on that, and I still haven't finished. But it's not easy to research the whole world. But yeah, this is because France.
Okay, thank you.
Yeah, so the things like for instance, there's nothing for the Commonwealth that if UK adopt something that some other countries would. What about for instance South Africa?
Yeah, this is not a finished work. So the gray parts don't mean that they don't use encryption at all. It's just that I just created a map of countries that I definitely know about what they are doing. And the other parts, it just wasn't so easy to see the official information. But this is something that I right now for the past days am working on.
And what's special about Ukraine? So what is this particular tweak that they use?
The special thing is that they are also adopting the standards from NIST, but not in their form. So, for example, they are creating their own algorithms, but they are using the winners from the competitions, which is not something that, for example, EU does. So that's why it's in a different color.
The talk is based on an interview of 21 results. So I want to know how you choose the sampling of the 21 people who gave the interview.
It's about your methodology. So how do you choose the people you interview?
Yeah, so for the first project, you have seen the table. I wasn't part of the project when they chose the people, but I know that they were chosen mostly by their background. So we wanted to have a diverse sample of people in the means of their background. We wanted to have someone from academics, someone from industry, government, and non-profits, someone who understands standardization, someone who teaches, someone who uses encryption in their businesses. And we wanted to, or the idea was, the more experience, the better. That's why I think I can show that. The years of experience is about, or on average, 20 plus. And for the competitions project, we chose the biggest or the most famous competitions, and we wanted to speak to people from each of them. So we reached to almost every publicly known participants of a cryptography competition, and then chose from there.
Any more questions? No. Okay. Well, let's thank Ivana again. Thank you.
Thank you as well. Thank you. And
So-
thank you for the invitation.
Yes. So I'm gonna stop the recording.